Hey there, AP scholars. I wish I was doing this live with you. I'm a little frustrated with the process here, but we're at home, we got to make the best of it, right? Right. Okay, so the next section has to do with the idea of introduction to titration. Now, again, this is me being good and following the AP format. I would not really normally introduce this for a while, but I do see why it fits into this unit, so we're going to talk about it. So what is a titration? Many of you didn't get a chance to do it because of COVID, so it might be a new experience for you. When we're talking about a titration, we're talking about a volumetric analysis, okay? We're performing an aqueous reaction, okay, in a controlled way so that we can measure volumes. Typically, we measure the volumes with burettes, okay? And we're mixing two different solutions. The known solution is generally referred to as the titrant, and the unknown is generally referred to as the analyte. Okay, we are analyzing the analyte. Okay, and when I say known and unknown, I mean I might know that this is HCl, for example, but I just might not know what its concentration is, or I might not even know what acid it is. It could go beyond that. But in either case, you would know the volume of the analyte because you're going to measure it first, and you're going to know the volume of the titrant as well as the concentration of the titrant because that is our known quantity. Okay, so it's just a volume to volume relationship. Okay, and we did some stoichiometry problems where we talked about mixing two solutions. That really is all that a titration is. Okay, now the question then becomes what are the equipment, and I talked about the burette already. We talked about the fact that many of you have used this type of clamp. It's called a double burette clamp because it can hold two burettes. There are single burette clamps. Burettes are used predominantly for titration because they are very narrow tubes, which means that their meniscus is not as big. So you're going to get a better reading of volume, okay? So it's a much more accurate means of measuring volume than a graduated cylinder, which we know is much better than a beaker or a flask. So burette is generally considered one of the best, although there is something, and we'll talk about it, that we give you a little bit better readings than even the burette. Essentially, what we have here at the burette, there's this little knob that you could twist, open and close. It's called the stopcock, okay? And we, can run this reaction a number of ways. Sometimes we put it on, we'll put a beaker or flask under the burette that's sitting on a stir plate so that it will stir the solutions as we go along. But this is the basic equipment. That's really all that it is, plus whatever we're collecting the liquid in. Typically, we use a volumetric flask for that. I'm sorry, no, I misspoke. Typically, we use an Erlenmeyer flask for that. But if we're using like pH sensors and whatnot, we need a bigger opening. So sometimes we actually will use a beaker as our reaction vessel. And of course, we've talked about the meniscus and reading the curve, so you got to read to the bottom of the curve. So even though, it looks like, we're somewhere, let's see, 9.123, looks like we're just between 9.3 and 9.4 at the top, we're actually between 9.6 and 9.7 down here. So I estimated it as 9.63. You might say 9.65. Whatever. Remember, we always estimate one decimal place in between the lines. Okay. Likewise, here I estimated that it was 24.15 because I thought it was pretty close to being halfway between 0.1 and 0.2. You might disagree, but then we could actually say if I knew this was my initial reading, this is my final reading, then my the amount of solution dispensed would have been around 14.52 milliliters. Nothing new there. Most of these titrations tend to be very colorful because we In order to know when the reaction ends, there has to be some kind of an indication. Now, in a precipitation lab, yes, we might see solid forming, but it's hard to tell when there's no more solid forming. And if we add too much liquid, then we've gone past what we call the endpoint of the reaction, where we're just not throwing excess materials in there anymore. Okay. Some chemicals change color on their own. Sometimes we add indicators. Okay, so this happens to be a very common indicator, phenolphthalein, and phenolphthalein turns pink in the presence of a base. So as we go from a pH of like 7 to a pH of 8, we're going to see the color change, and that's how we know that the reaction has changed. But we'll get into the whole pH thing later on. That's not really our topic at hand. Okay, but the point is that we need some color to help us see what's going on so we know when we're at the end of the reaction. Acid-base reactions are by far the most commonly used for titrations. They are not the only ones. Okay, redox comes up a lot because redox reactions, as ions change charge, transitional metals especially, they change colors. Okay, so again, that allows for the color change, so it's an easy means of measuring where the reaction ends. Precipitation reactions you can do with a scale and try and keep track of mass and everything. They're really a pain in the butt. And I'm not even going to begin to explain complexometric reactions because we haven't talked about complexes yet. And who knows if we'll get to that point this year. So, yeah. Okay. I said there was a more accurate device, and those of you in research in molecular genetics are used to these micropipettes. Okay. It is a very, very efficient way of measuring small volumes, even way more efficient than the burette, and burettes are very efficient. Okay, so if we're doing a lab on a micro scale where we don't want to make liters of solution, we only want to make a few milliliters of solution. Okay, doing a titration with micropipettes will make it much more efficient in that way. The problem becomes two things though. One, if we're relying on a color change, the color may not be as visible in a small scale as it is in a larger scale. Okay, so knowing when you reach the endpoint can be very tricky. Okay, also, if you're using a pH sensor or whatever else, you need a bigger volume for the sensor to actually work. It has to submerge. So if you're only using a couple milliliters, you're not going to get an accurate reading. So even though these are way more efficient, they do have drawbacks, and that's why typically we are going to talk about titrations in terms of burettes. Okay, so that's the intro to titration. We'll get more specific with titrations later. We're going to do a little either a lab or a demo with it along the way, but that's it for now. So, yep, section 6 out. Bye.